I want to show you what it looks like when you move in and out of containers, and I think this will actually help explain what override means. So let's go to that. You can see I have this pipeline where I basically have steps that are using Go, I have steps that are using Java, I have steps that are using .NET. So I'm going to run this in debug mode, and I'm going to set before and overrides on these, which is going to allow you to see exactly what happens when we do that. So I'm going to set a before and an override on this Golang, and I'm going to set another one on Java. Actually, you know what? I'm going to set them all into parallel. Let's just set these all on override. And what we're going to do here is we're actually going to move in and out of containers. And I'll show you some cool stuff. All right, so I'm going to hit continue, and this will go ahead and kick me off. All right, so when I execute before, it's actually executing before the step has started, which means that it's actually going to give me a debug console outside of the step, right? So for example, Go, you can see is not installed. So it's not available right now. If I hit continue, it's going to move me into the override. And you can see in this step, all of this step is doing is just echoing a hello world. So we're going to override that and replace it with my own content, essentially. So I'm going to hit continue. And this is actually going to start up the container. You can see the container starting up and the relevant tools for the debugger being installed. And this will allow me to now move inside of the container where I have access to that container tooling. So in this case, I can basically run Go, that kind of thing. All right, so now if I run the Go command, you can see that I actually have it available because I'm now executing inside of that step. And if I cat out the OS release, you can see that we still are on Alpine, but it's because this step is the Golang Alpine image. So I now have all the things that I need available to me to work on Go. So I'm going to hit continue. This is going to run a Java step and a .NET step. And I want to show you what happens when we actually run steps in parallel. So we have the same 3 steps, but instead they're going to be running in parallel. So we're going to move forward in our pipeline. And this is going to do those simple hello worlds. So hopefully you understand now what an override does. And I'm going to show you another kind of interesting scenario here. So, oh, you know what? I should have. Well, so in the normal before or after a step, the tools in these steps aren't available. So like Java's not available, Go's not available, .NET's not available. So what I'm going to do, I'm going to add afters on these as well. So you can see the before and after. And these are going to start up 3 debugger consoles at once, one for Golang, one for Java, and one for .NET. And again, these steps could be doing anything. These are arbitrary steps, right? So these could be steps that are doing my running my CI tests. These could be steps that are running integration tests. These could be steps that are gathering keys. These could be steps that are pushing alerts to Slack. Whatever it is, I can actually access them here. So here now I'm in the Golang. You can see I'm in the override right now. So if I run Go, that's going to work, right? Let's see Java now. Now if I'm in the Golang one, hang on. Let's try to run Java. What happens? Nothing. It's not found. What about .NET? Also not found. So let's go over to Java. And if I do Go, not found, Java, now that's found, right? And .NET, not going to be available, right? But if I go into my .NET step and my debugger, I'm now going to have .NET available, and Go will not be available, and Java won't be available. But remember, I can actually interact with this shared volume in real time. So I'm going to do a .NET rules over here. And if I go and look over in Java, and I actually check my volume, you can actually see that .NET rules is now available. And so now if I do another one, like in this case, let's, I guess, do Java rules. Now you can see while I'm in the Java container, I can still see that. But if I go over to my Go container, I can also see both of those rules now available. So you can see how we're all interacting with the shared volume. Now, what would happen if we were devious? What would happen if we were essentially dumping gigabytes of data from one step? What would happen to the other step? So let's actually look at that scenario. So what I'm going to do is this is a dangerous command. I'm going to cat out dev0, and I'm going to pipe this into oh no, what have I done .text. All right, so when we were playing around with this, I showed this with a colleague, and he said, "This is a dangerous command." Yeah, it's definitely a dangerous command. So what's going to happen? Can I actually go and engage with that? Well, if I go over to my Java here, you'll notice that I can still engage. And what's going to happen, even if I tried to cat out this, oh no, what have I done text, which you can see it's running right now. And actually, let's just verify that it's running. Sometimes this will actually cause a little bit of a lock. So now my console may not respond on this one because it's actually taking up all of the resources. So I basically spam myself out. So I'm gonna break this process, and we can do an LSIH, and you can see that my oh no, what have I done just dumped 11 gigs of zeros. So now you can see some of these different scenarios of what would happen. All right, so we're all back squared away. Now it will eventually just run out of space, and you'll have to delete it in order to do anything. But my consoles and terminals, you can see now this was kind of locked because of the CPU was basically pegged reading out zeros, so it caught up once that was completed. So some different scenarios of how these containers are interacting, even though they're essentially going to be running off of the same resources. Now, of course, if I were to continue and go afterwards on this Go image, that Go would no longer be available, right? So you can see kind of how we're moving in and out of containers, accessing different tools, moving out of the container, getting different tools there. We're using that shared workspace that persists through the entire container run. Normally, when you run a Codefresh pipeline, that volume is actually preserved and kept persistent and distributed as one of about 50 different speed optimization things that we do. But in debug mode, that volume is actually not going to be persistent and carried into normal pipeline execution. We wouldn't want it to, because we're doing whatever kind of funky stuff here, right? So we're happy with this. You got to see what it looks like when we run 3 in parallel. You can see us moving between these different debuggers.